Today we're going to discuss this Formative Practice 5.1b. Okay, so you need to copy down all the exercise here. Question 1. The diagram shows the graph G. Okay, so this is a graph. Determine whether each of the following graph is a subgraph of G. So you just compare. So Q, yes, we have Q here. S, yes. P, yes. So E1, E1. So this is correct. E7, E7, yes. E6, E6. Okay, so this is part of the graph G. Therefore, this is the subgraph of G. So this is yes. This is a subgraph of G. 因为这一个是它的一部分，而且它这个号码都是对的 ，P、Q、S、E1、E7、E6 都是对的。Question B. So you just compare P, P, Q, Q, R, R, S, S. Yes, all correct. And then we compare the age. So this is E1, yes. E4. This is E7, not E4. Okay, this is supposed to be E7. E3, E3, yes. But here, this is wrong. This is supposed to be E7, so no. This is not a subgraph for graph G. C, PSR. Okay, PSR, yes. Then we have E6, E4, E5. E6, E4, E5, yes. So this is a subgraph. For D, we have QS. Q, but this is R. Okay, this is supposed to be R, not S. So no, this is not the subgraph for graph G. E, okay, PQRS. P, okay, this is PQRS, that is clockwise. But here this is anti-clockwise. Okay, so no, this is not the subgraph for graph G. F, PQRS, clockwise, PQRS, yes. Then you compare the H. E1, E1, E2, E2, E3, E3, E4, E5. Okay, E7, E6, E7, E6, yes. So this is the subgraph for graph G. Number 2, draw 4 subgraphs of each of the following graph. Okay, so subgraph number 1. Okay, we can remain P, Q, R. Q, R. So you have P, Q, R. Then you follow the H here. E1, E2, E5. Okay, this is E1. This is E2. And this is E5. Okay, this will be our subgraph number 1. Then number 2. So let's say I want PSR. Okay, so I draw. You just follow the direction of PSR. So P here, S, and R. So I have H4, H3, and H5. Okay, so I draw 3 edges. You have to draw using ruler. So this is E5, E3, and this is E4. For subgraph number 3, so let's say I only want S and R. I can draw only S and R with E3. Okay, so here I have E3. Subgraph number 4. Okay, I want all of them. Yes. So you can draw P, Q, R, S. P, Q, R, S. Then you follow all the edges here. Okay, this is E1. And this is E2, E3, E4. And this is E5. Okay, and of course you can draw many more subgraphs for this graph. Okay, you can remain only PR, so on. Question 3. Determine whether each of the following graph is a tree. Justify your answer. Okay, for this one, whether or not this is a tree, we can use this. Number of edges must be equals to number of vertex minus 1. Okay, so for A, we have 1, 2, 3, 4, 4 dots here. Okay, this one, number of vertices equals to 4. And number of edges equals to how many lines here? 1, 2, 3, 3. Okay, so number of vertices equals to 4, 4 minus 1, so equals to 3. Yes, this is the same, right? Number of edges equals to 3, number of edges equals to 3. Therefore, A is a 3. Yes, this is a 3. For B, we have 1, 2, 3, 4, 4 vertices. So our number of edges, we have to follow this formula. So 4 minus 1 equals to 3. But here we only have 2 edges. So this is not a 3. Okay, because number of edges must be equals to 3. It has to fulfill this formula. Okay, so this one, justify your answer. You just write that number of edges not equals to number of vertices minus 1. We have to give the reason. This is not equal. Okay, for C, we have 1, 2, 3, 4, 5, 6. 6 vertices. So the number of edges must be 6 minus 1 equals to 5. Then we count how many edges here. 1, 2, 3, 4, 5, 6. Okay, this does not fulfill the formula here. So this is not a tree also. Okay, so you write down C is not a tree. Why? Because number of edges not equals to number of vertices minus 1. For D, so number of vertices we have 1, 2, 3, 4, 5, 6. Number of vertices equals to 6. So number of edges must be 6 minus 1 equals to 5. 1, 2, 3, 4. We only have 4 edges here. Therefore, this is also not a tree. Okay, and then your reason you can write number of edges not equals to number of vertices minus 1. Same reason. Okay, for E, so we have 1, 2, 3, 4, 5. 5 vertices here. So number of edges must be 5 minus 1 equals to 4. But you count how many edges we have here. 1, 2, 3, 4, 5. 5 edges, 5 lines here. Therefore, this is also not a tree. For F, we have 1, 2, 3, 4, 5, 6. 6 edges. We have number 4. Draw 3 trees based on each of the following graph. Okay, so for A, for trees, we have to remain all the dots here. Okay, so you have to draw the dots first. 1, 2, 3, 4, 5, 6. I have 6 dots here. Then we have to connect all these 6 dots. So number of vertices equals to 6 because we have 6 black dots here. Therefore, number of edges must be 6 minus 1 equals to 5. You can only draw 5 edges here. 我们只可以画5条线，因为这个是一个 tree 的一个很重要的特点。So we have to connect all the vertices. Okay, you cannot leave out any vertices. 你一定要把所有的点连起来，你不可以少掉一个点。Okay, so how to connect these 6 vertices using 5 lines? Okay, so first one, we can draw like this. 1, 2, 3, 4, 5. Okay, so this is our first tree. I have 6 dots and 5 lines on it. So first we draw out 6 dots. 1, 2, 3, 4, 5, 6. Okay, we have to follow the patterns given in the questions. So we have to join these 6 dots using 5 lines. Okay, so we can draw like this. 1, 2, 3, 4, 5. Okay, all dots are connected and only using 5 lines. And these lines are given in the question. Okay, 3. So we draw out 6 dots first. How to connect these 6 dots? We can draw like this. 1, 2, 3. Okay, I have a line here. Okay, so I can draw like this. 3, 4, 5. So all the lines are given. 1, 2, 3, 4, 5. Okay, so this is the trees for graph A. Okay, so you try to draw 3 trees for graph B. Okay, for graph B we have 1, 2, 3, 4, 5, 6. 6 vertices. So number of edges must be 6 minus 1 equals to 5. So you only can draw 5 lines connecting these 6 dots. Okay, you try first. Number 5. Draw a tree with 5 vertices. Number of vertices equals to 5. Therefore, number of edges must be 5 minus 1 equals to 4. Okay, so just draw any 5 dots. Okay, let's say like this. Then you connect these 5 dots using 4 lines. So 1, 2, 3, 4. Okay, this is a tree. For B, number of vertices equals to 6. So number of edges must be 6 minus 1 equals to 5. So just draw out 6 dots. Let's say you draw like this. 3, 4, 5, 6. And then you connect these 6 dots using 5 lines. So 1, 2, 3, 4, 5. Okay, this is our tree for B. C, number of edges equals to 3. Then how about number of vertices? Okay, for number of vertices, we have to plus 1. So 3 plus 1 equals to 4. Therefore, you just draw out any 4 dots. And then you join these 4 dots using 3 lines. Okay, so you can write this 1, 2, 3. This is also a tree. Okay, you try to do D yourself. Number 6. The diagram shows a graph G. Based on the graph G, draw a subgraph with 4 vertices and 5 edges. Let's say I want to draw QTSR. Okay, I want to remain these 4 vertices. So I can draw QTSR. Okay, you have to write down. This is QTSR. Okay, this one is 4 vertices and then 5 edges. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So this is our answer for A. B. A tree involving all the vertices. Draw out all the vertices first. So P, Q, R, S, T, U. Okay, so I have a line here. I can connect like this. I have a line connecting P to Q, so I can draw like this. Q to T, Q to S, and Q to R. Okay, double check first. So I have 1, 2, 3, 4, 5, 6. 6 vertices here. So number of edges must be 6 minus 1 equals to 5. So I can only have 5 lines here. 1, 2, 3, 4, 5. Yes. So this is the answer for B. 7. Without drawing the graph, determine whether each of the following graph is a tree. If it is not a tree, justify your answer. Okay, so this one, you just count number of vertices and number of edges. Okay, number of vertices, I have 1, 2, 3, 4, 5, 6. 6 vertices here. So for a tree, number of edges must be 1 lesser than the number of vertices. So 6 minus 1, it must be 5 only. So you count 1, 2, 3, 4, 5. Yes. So this is a tree. Okay, this is a tree. Because it fulfills the formula for a tree. B. Number of vertices, I have 1, 2, 3, 4. So number of edges must be 4 minus 1 equals to 3. But I have 1, 2, 3, 4, 4 edges here. That means this is not a tree. Because number of edges not equals to number of vertices minus 1. For C, I have 1, 2, 3, 4. 4 vertices. So number of edges must be 4 minus 1, which is equals to 3. But I have 1, 2, 3, 4. 4 edges here. Therefore, this is also not a tree. Because number of edges not equals to number of vertices minus 1. Okay, you try for D. Number 8. The diagram shows a simple graph. State the number of edges of the graph. So how many edges here? Okay, we can label it. So this is E1, okay, this is E2, and this straight line is E3, and this is E4, and this is E5. So number of edges equals to 5. 我们有5条线在这里。B. On the graph, draw an edge so that the graph will become a tree. So for a tree, number of vertices equals to 1, 2, 3, 4, 5, 6, 7. I have 7 dots here. So number of edges must be 1 lesser than number of vertices. So 7 minus 1 equals to 6. But here I only have 1, 2, 3, 4, 5. 5 edges. Therefore, I have to add 1 edge so that this becomes a tree. Okay, so you can draw the edge here or here. So that we have 6 edges here. That's all.